Okay, hi, so this is the second tutorial and this is going to be dealing with Excel. So we're going to walk through 4 phases. The first is example of calculating sums. The second is we're going to be showing you how to use more complex formulas, organizing data and graphing, and then we're going to take the graph that we created here and edit the graph to our standards. Alright, so for instance, if we had a column that had a bunch of values in it. Let's say how much money one person was having in his bank account. 300, 400, 147. And you wanted to calculate the sum of this column. One of the easiest ways you could probably do it is just to select the entire column, go up to formulas and click on auto sum. Now that's one way to do it. So a better way to do it would be to get used to writing Excel formulas. So if we had the same thing here, the way I'd write an Excel formula is like this. I would select a thing, select a cell that I want. I'd write equals. Equals would tell Excel that I'm about to write a formula now. And then I'll type in sum, because sum tells Excel that I want to sum the number of cells that I'm creating. I'd select, I'd have an open bracket now. I'd select the topmost. Alright. I'd hold down the shift key and select the bottommost. So what it does, it gives me C5 to C10. Close bracket, press enter, and I get the same value. Alright? The other way I can do it is, instead of selecting anything at all, I could just type it all out. So I can type in equals, capital sum, open bracket, and this cell right here is D5, D at the top, 5 from the right, left, and this cell here is D10. So sum D5 colon D10, close bracket. That gives me the same thing. Now, one of the questions I asked you in class is, what if you had a continuous? You had a continuous list, a never-ending list, and you always wanted to find the sum of it. So what you would do is, for instance, let's say these are not continuous lists. These are finite lists, and this would be an infinite list. So the thing with finite lists is, if I change the value on a finite list, like let's say 300, the value of my sum would change. If I change this value to, let's say, 20,000, the value of my sum, as you see here, would change. But in an infinite list, where, for instance, let's say this didn't exist, but I could add infinite values, like let's say I added, let's say these are bank account transactions. See, this sum value doesn't change. So the way you'd make a sum in a list of infinites, always sum, is like this. You'd have to select a separate column to present your sum at. Let's select this, and this would be our separate column. We'd get rid of this formula here because this is actually a formula and not a part of the list. Right? Let's select this column here to be our sum. Okay? Sorry, I'm just gonna insert a column here to give us some space. Alright, let's say this is our sum. So what I'd do is, over here, I'd click equals sum. I'm sorry, let's do that again. Equals sum, bracket, and I'll just select this entire column, all of column D. And notice the formula for that is D colon D. That means all of column D. And close bracket, enter. Oh, I'm sorry, put the close bracket in the wrong place. There you go. So now, what's cool about this using infinite lists is if I add a value, if I changed a value on my list, like let's say this value, if I changed it to 20,000, my sum would still change, but I would also be able to just add values to the bottom. See, my sum changed again. Notice my sum here is continuously changing. So using this formula, the whole column formula, D colon D, for finite lists, for infinite lists, over this formula, which specifies from a starting point and an ending point, this can have really great applications. For instance, if you wanted to keep track of a bank account and you don't know where your bank account starts and stops, but you have money constantly flowing in and out, so you would rather use something like this. Okay? All right. Fantastic. Now, let's come here and let's do some organization of data before we go on to doing using formulas in a little bit more depth. I'm going to delete some of these to give us more space. Yeah, no, maybe I'll just move these down. Don't worry about what I'm doing right now. I'm just making space so I have more area to work. Alright, so these are sums. I'm going to put them in bold. And this is a sum. I'm going to put it in bold as well. Alright, now let's make a table like we did in class. Let's take for example the weight of the different students in our class. We'll take their height. Find a ratio of their weight against their height. And then we'll do some, let's say we'll just do some weird formula so we can play around with functions a little bit more and the equal sign a little bit more. And this is just for fun. So I'm going to make up some random weights in our class, and the weights are going to be, let's say, I don't know, 55 kilogram, 44, 56, 34. I don't think there's anyone who would be 34. 78, 91, 93, and 74. Okay? And I'm going to give them heights. So this person should be kind of small. This person should be slightly larger. No. 140. This person will be really small. 120. Larger. 150. 191 can be 190. Oops, sorry. 87. 76. Okay. So these are fairly good weight ranges. So as you see, when I look at this table, there's something that is very confusing. So for instance, I don't know what unit these numbers are. I have no idea because I didn't specify it. So I should always add, and this is just a standard practice, the units to the heading of the column. So this is kilograms, this is centimeters, and that makes these values a lot more obvious than they were at the beginning. Now if I wanted to find the ratio of the height to weight in all my classes, I'd start off by telling Excel that this is a formula, so type in equal sign, right? And then it will just be as simple as the height divided by the weight. That's it, enter. So I got 2.95. So this is every 1 kilogram for this person is equivalent to 2.95 of its height. This is the ratio. So I want to be able to apply this same formula, this divided by this, to the rest of the people in this classroom. So I just come to the bottom of this Excel cell where my cursor changes color. See, over here it's white, over here it's black. And I'll just drag it down to the bottom. And that will give me, a different, this will calculate the ratios for all of them. If I double click on a cell, I could see its formula, and you can see it adjusted. Excel intelligently adjusted the formula. So it uses a different cell for each calculation. Okay, so I want to change some of these. I want to make this one, 180, and I want to make this one, and I want to make this one, let's say 40. I'll make this one 120. Okay, and yeah, maybe I make this one 188. Sorry. All right. So one of the problems with this representation of data is the fact that they're all a different decimal place. There's all to a different accuracy. And that doesn't help the presentation of our data. All right? That doesn't help the presentation of our data because it's not easy to read. So to make this more readable, let's select this entire cell. Okay. And let's click on sorry, give me 1 second. I think it is well, what you can click on is, on a Mac you can click Command 1, and on a Windows you can click Control 1, and it should bring you up to this format cells that I can't seem to find anywhere else. If you go into format cells, again, on a Mac it's Command 1, and on a Windows PC it's Control 1, as long as you're using Microsoft Office. And let's go to alignment, let's go to general, and let's give this cell a type. So we want all of the cells to be the same number of decimal places. So we can go to number, and we can specify round every value up in the cell to 2 decimal places, or you can say 3 if you want, or 2, and click OK. And now you can see what happens is all the numbers get rounded up, and it's just easy to read, and that's easy for comparison purposes. So just to show that again, I could select the entire cell, the list of cells, click on Command 1 or Control 1, depending on whether you're on Windows or a Mac, and click on categories, numbers, decimal places, and I'm just going to change the decimal places here just so you can see how it changes things. Click OK. All right. It just makes everything easy to read. So every time you're creating an Excel sheet or a table or anything, make sure that each of your columns can have different decimal places across columns. Like the height column can be a different decimal place from the ratio column. But at least make sure that for each column there is a unification in the number of decimal places used. So just to show you that I could use some complex formulas, and this means nothing, okay? But just to show you that there can be you can use complex formulas just by using brackets. What I'm going to do is I'm going to say that I'm going to take the number. I'm going to take this number, which is C7. Okay, I'm going to divide it by this number, which is H7. Okay, I'm going to take this. I'm going to take that. Okay, I'm going to take that. I'm going to use that, multiply it by its ratio. Okay, which is I7, and I'm going to take the whole thing. I'm going to minus 33 from it, and this means nothing. I just want to show you that you can do pretty complex formulas in Excel just by making sure you have your brackets in order. So a plus is a plus, a minus is a minus. Okay, the star sign, which is shift and the number 8 on the keyboard, represents multiplication, and the hash sign, which is the same button as the question mark on the keyboard, represents a division. Okay, and if you clicked enter, you'd see it just does that calculation for you. This formula has absolutely no meaning whatsoever. It's just to show you that Excel can do quite complex formulas. Sorry, by the way, this is not C7. It should be G7. Okay. Okay, all right. And if I were to take this and just to drag it down all the way, yeah, so it would do that for me. Minus, maybe I'll take this minus 33 out and like enter that. So G7 divided by H7 multiplied by L7. Since I took the minus thing out, I wouldn't need that. And I could drag this formula down again. So in this case, it just happens to be all ones. You do G7 divided by H7, so 44 divided by 130 multiplied by 2. And that should give you 1, because what you're doing is you're taking that and that and dividing it by 1. So if you didn't multiply it by this, but you multiplied by, let's say, a constant, like let's say 3.14, press enter, you get something completely different. Okay. This is just to demonstrate that Excel can do complex formulas. All right. And again, for this column, if we would like to have them all show the same number of decimal places, you'd select the column, press Command 1, click on number, click on 2 decimal places, and click OK. And we'll do the same thing for this. So there's more unification between our tables. We'll make it 2 decimal places instead of 3. Okay? Now, one of the things about creating tables and organizing data is we should be able to look at a table of data and know right away what this table is about. So what I'm going to do is I'm going to give this table a title. Okay, this is going to be height and weight in grade 10. Okay, but as you can see, this is one title which is supposed to go through one cell, but it goes across 1 cell, 2 cells, 3 cells, and 4 cells. So let's to make this a nice title, let's select the cells that the title should go across. Okay? And again, Control 1 or Command 1. Now go to Alignment, click on Merge Cells, click OK. And now you'll see that the whole title, which spans throughout the entire table, is just one cell. To make this title nicer, we should definitely bold it. Alright, and we should also center it. Alright, okay. Alright. So, we should also make it slightly bigger to show that it is a title. Now, we can also bold these, and we can center these. And we can center all our values if we would like to. Alright. So now let's do a little bit more on the formatting bit. If we want to show that this is a table, it's specifically a table, you can select the entire table, click on this, okay? This button is called Apply Borders to this selection. And it's important to learn how to make borders because it can segregate our data. And click on Outside. And you'll see it made a nice little border around our table. If you want to make this border thicker, you just click on this again and say thick box border. Okay? And we should do the same for every column because that segregates our data a little bit more so we can see that each column is slightly different. Okay? Outside borders. Again. Outside borders. Again. Outside borders. So you see now that I've created outside borders for each of my columns, it's gotten rid of my thick border all the way around. So I need to select the whole table again, click on this, and click on thick borders. Now my table is kept quite nicely. I might put another thick border around this cell on its own, just for a nice presentation of my data. Okay? Alright. Fantastic. Alright, now what I want to do is I want to plot a graph between weight and height of this classroom. So I have a visual representation. We did this section right here in this, just to show that this, although this column means nothing in our data, I wanted to show you could use complex formulas here. So I'm going to delete this over here. Now, let's graph our data. So to graph your data, you need to select the data that you want to be able to graph. Select that data. Let's forget about the ratio for now. And then you'd go to the top and you'd click on Charts. And if you're on a Windows computer, then you'd click on Insert. And after you click on Insert, you'd see Scatter. Okay, but on a Mac, you'd click on Charts and you'd see Scatter. So let's plot this graph as a scatter graph. All right. So there's our data. It's on a scatter graph now. Now we got to do something more analytical with this chart so we can understand it and read it better, because this is not very perfect. So the very first thing is this title, it means nothing. So let's change it. It should be called height and weight in grade 10. Okay, so now people know what they're looking at. This key, it means nothing either, because as you can tell over here, we've got weight on the x-axis and we've got height on the y-axis. Yeah. So having this key of height over here, it genuinely means nothing. In your case, if this key means something, if you're working with different data, then keep it. But since in this key it doesn't make any sense, we can just get rid of it. All right. So now let's look at our data very carefully. It's actually quite easy to tell that there is nobody under 30 kilograms of weight in this classroom. So to make this table easier to read and to better utilize space, what we can do is we can start off our axes at 30. Okay? So we'd right click on this, on the bottom axis, and you'd click on Format Axes. Okay? When you click on Format Axes, you'd get a minimum and a maximum. So again, let's see, the maximum weight of anyone in our class does not exceed 100. The minimum weight does not exceed 30. So let's make the minimum 30. Let's leave the maximum at 100, and we'll leave the major units at 10 and the minor units at 2. Okay? And what you can see now is the graph is more well spread out, and it gives us a better visualization of what our data looks like. We can do exactly the same thing for the height. It's very obvious that there's no one in our class less than 100 centimeters tall. So let's right-click on that axis, click on Format Axes, okay, and let's make the minimum 100. Okay, the maximum can stay 200. There is no one greater than 200. The major units can stay at 10. The minor units can stay at 2. Click OK. Now this graph is much easier to interpret than what we had previously. But we still have some problems. So for instance, it's not very clear to say exactly what this point is. If I was guessing off this, I would say somewhere between 55 and 60 was this student's weight, and his height was about 140. But it's not very, very obvious to me. So to make it more obvious and to make this graph more readable, we should always add grid lines to it. So right-click on the axis again, add major grid lines. Right-click on the axis again, add minor grid lines. And this makes it a lot easier to read. And we should do the exact same thing for this side. We should go add minor grid lines. And now you can see our chart is actually quite simple to read. It's much easier to read. We know what data is where. Okay? We can format it so it looks a little nicer also. So if you drag your cursor around, you can also make it so the major and minor grid lines add up and they're more square than they are rectangular. And that makes it easy to read as well. Okay? So at this point, what you want to do is you probably want to give your chart some axis labels to make it even easier to read. So you'd go to Chart Layout, and we have a chart title already. We need axis titles. So we'd click on Axis Titles, and let's do the horizontal axis first, and say Title Below Axis. All right. And then we would click on Axis Titles again, do the vertical axis, and we do the rotated title. This is probably the best way to do it, I think. All right. All right. So let's say the axis title is going to tell the viewer what value is represented on the x-axis. Okay. Sorry, excuse me, just give me 1 second. Oh, okay. All right. All right. So it's going to tell the viewer what value is represented on the x-axis, and weight is represented on the x-axis. So we put in weight, okay, in kilograms. All right. And height is represented on the y-axis. Sorry. So we put in height in centimeters. And this is how you make a fairly good graph. You can play around with the types of data and how you format it. Play around with the types of charts available. There's lots of different ones, okay? You can play around with a lot more functions here and there. You can also, what might be useful for some data sets, especially for physics class, is you can also add trend lines. So you can right-click on any of your data points and click on Add a Trend Line. And it gives you a trend line, which is quite cool. And you can decide, you can choose between whether you want the trend line to be linear, logarithmic, polynomial, to a power, an exponential, or a moving average. And one of the cool things you can do is you can go to Options, and you can display an equation on the chart. And if I click OK, it gives me an equation of this line. So what this equation tells me and what this line tells me is that there is some sort of a linear correlation between the data sets that I have. So there's some sort of a linear correlation between weight and height. So generally, the greater your weight is, the greater your height is. This will not always apply. Of course, I made up this data set. It means nothing at the moment, but it's just a good way to know. So all this that you've learned today should be useful in many different classes and not just IT. And this was our crasher course on Excel and Microsoft Office. And as long as you can do the things that I've shown here, you're going to be great for the assessment. All right. Thank you very much. See you guys next week.